So now we're going to transition into a number of presentations around connected and autonomous vehicles, sensor fusion, and millimeter wave-based V2X. I know that we're getting queued up to give those presentations. I know that first up is going to be my good friend, Dr. Sujit Day, and want to see that we're getting the session 7 going, and here we'll be doing more of a bit of a deep dive into the technology again. Arvind did a great job talking about what the vision can be, but also what is in flight right now, what is happening, what is getting deployed, what the opportunities are that are really landing on the ground, that are being invested in, that are being constructed and built. Here are now some opportunities to discuss even further the technology that is powering a lot of these big moves. So Dr. Day, I'm looking for his camera. I will introduce him. There he is, my good friend. And as I mentioned, we've had the opportunity, or as he mentioned, we've had the opportunity to work together in the smart transportation improvement space. And I always love getting to spend time with such brilliant thought leaders, researchers, and folks that are doing the cutting edge in technology. I work in government, which rarely does cutting edge and government go together. So these are always inspiring to also understand what the future of the technology is. By way of introduction for Dr. Day, I did pull up, even though I know his resume quite well, I did like that on the site it said Sujit Day Director, because it seems like it has so many titles, the laundry list probably go on and on, but you most likely know him since he is the director for the Center for Wireless Communications, also the Institute for the Global Entrepreneur. He heads up the Mobile Systems Design Laboratory. And I know he didn't want long introductions for everyone since many folks here are colleagues, but the last thing I would say is that Dr. Day really is an innovator in thinking about the future, not just of technology, but about cities. And so with that, I'll kick it over to you.
Thanks, David. And I was waiting for the slides to be shown. Dishan, are you able to show the slides? I'm happy to share the slides from my laptop. The slides, it was my fault. I uploaded them very late. Do you want me to show my slides? Let me go ahead and share my slides.
I'm just being able to access the slides, and they're downloading now. So it's going to be a minute. So if you can do it from your end, it'll probably be faster.
Okay. Thanks. Hopefully all of you are able to see my slides.
Yep, you're good to go.
Okay. Thanks, David. And Arvind, thanks. Enjoyed your talk. So I'll be giving a high-level overview of the work that we have been doing for the last 3 years at UCSD, sponsored by Center for Wireless Communications, but also we formed a new separate program, the Smart Transportation Innovation Program, where you see there are many other partners, including city partners and auto partners. And so it's a joint work between the Center for Wireless Communications and the STIP program. And one of the things that we really think is a fundamental building block, but also a fundamental platform for the future of mobility is the ability to fuse from multiple sources, multimodal data. And what I mean by multimodal data is that consider any vehicles, there are more and more sensors in them. There are, Arvind mentioned about drones. So there are going to be various forms of transportation. So we would like to get the data from them, but multiple sources at the same time. And also more and more cameras and LiDARs and other kinds of sensors are being deployed in the streets. So data from there, pedestrians, and also something that we have not done yet, but we plan to integrate also the data that comes from EV charging stations. All of these are live data. And so we are developing this platform, a set of algorithms, if you will, which can do multimodal, multi-source, cooperative data fusion and predictive analytics. And I'll give you examples of that. Now, there is a lot that needs to be done, which we honestly have not been doing as much. For instance, how to preserve security, whatever privacy, trust, ethics, and so on. But we are slowly and slowly getting there, building this platform, to start with. Now, how do we share so much of data going back and forth between the various vehicles, pedestrians, street IoTs, and so on? So one way of doing it would have been V2X technologies. That means shared data between different vehicles, shared data between vehicles and pedestrians using V2V and other kinds of V2X family of technologies. But what we are doing is all the data are going to an edge node, and I'll come to that. And the edge node is the one that is doing the fusion. And the edge node is the one which is doing all the analytics, all the predictive intelligence, and so on. And then sending the intelligence back to the users, back to the road users, including vehicles, maybe aerial users, including the drones, and so on. So, and I'll talk about that briefly. So this is one of the applications. This is collaborative perception and guidance from the edge. So today, all the vehicles have ADAS systems installed inside of the vehicle, and all the data is collected inside of the vehicle. But if you think about it, if you are wanting to share, the data from various different vehicles, that is not very scalable. Also, CV2X has about a megabits per second data rate, which is not very good for this kind of data sharing. The other thing is that we cannot expect all the vehicles to be smart vehicles, right? We cannot expect all the vehicles to have all the different sensors. Now, the methodology that we are proposing, the approach that we are driving, essentially means that all vehicles, doesn't matter how smart they are, what kind of sensors they have, they just send their data to this edge. Similarly, the streets, IoTs, and so on. And then both multimodal data fusion and edge-based multi-source fusion happens. The multimodal data fusion can happen in the vehicles itself, but can happen at the edge. But the edge-based multi-source fusion can happen only at the edge because it's multi-source data. And this is another example of an application that we are working with along with Qualcomm, where this is data collected inside of the cabin. This is data which is camera sensors, vehicle telemetry data, audio data, and so on, used to understand what is the driver's state of mind, are there any driving anomalies that are notable, and what is the driver's intent. And this data also can be shared across to this data sharing platform so that it can help in providing guidance to all the neighboring vehicles and pedestrians and bicyclists and so on. We, in terms of how we are doing it, I mentioned edge-based, right? So what we are doing is, and this is in collaboration with Qualcomm, what we are doing is, and also I need to acknowledge Primovin, San Diego company. So we are developing a prototype of what we call an intelligent RSU. And in that intelligent RSU, there will be the functionality of radio functionality, enabled by small cell, but also functionality of this intelligence layers hosted by a mobile edge computing node. And in our worldview, that because we'll be installing many of these, we don't want to increase the energy consumption. We don't want to increase the carbon footprint. So we are designing these carbon neutral, fully sustainable, renewable energy driven RSUs. And just wanted to show you some quick pictures of it. Now, I already mentioned this, that because vehicles are evolving where there's, instead of just some simple sensors and actuators and microcontrollers that used to be even 10 years back, now we have a plethora of cameras and radars and lidars, and there is a layer of software that needs to be executed. What we are enabling, using again our intelligent RSU, is we don't need to have all of these multimodal fusion, tracking, planning, and all these things execute on the vehicle. Some vehicles may not have as much computing capacity, for instance. So we are developing algorithms how to particularly these tasks that would have originally run on vehicles across to the intelligent RSU. So some of the tasks and parts of the tasks will be running on the vehicles, and some will be running on the RSU, and all this will be dynamically managed depending upon the wireless network conditions. And so the overall network architecture is like this, that, and many of you have seen this diagram because we have been building this testbed for about 2 years now. So the Region will be divided into these small cells. Each of the intelligent RSU will be controlling, will be doing the data fusion and the perception analysis and the intent analysis and all these things for the local area. And each of these local areas, these local zones, will be overlapping so that when a vehicle, a pedestrian, a bicyclist goes from one region to the other, they just get handed off to the next RSU. Now, one of the fascinating things here that I already mentioned is hybrid computing, but the other thing is hybrid communications, because we are strong believers that yes, cellular V2X, but why not use millimeter wave? Because that has the advantage of very, very low latency. Of course, the problem is that there can be anything that is blocking can reduce the signal strength. So we have been doing research on those aspects also. How do we bring in millimeter wave based V2X or millimeter wave working in outdoor? And Shinu will be presenting on that later on. The fusion work will be presented by Trong and Dinesh. And so with that, I stop. I just wanted to mention that wanted to thank so many of our partner companies, including Qualcomm. They have been working with us to enable CV2X enhancement to this test bed, and to Honda Research America and Honda Motors for providing us vehicles with telemetry and telematics data and collaborating with us on that side. And also Keysight and the Keysight Automotive Group, which is developing this platform which can help us simulate. Talking about that, just very, very quickly, something that will be, I think, very, very consistent with what has been something that I've seen over the various sessions, and that is how do we simulate all these things? So on the left-hand side, there are all these different sensors. On the right-hand side, there are these various kinds of networks, right? How do we, one thing is the test bed that we are developing, but as we know that on the test bed, we cannot try out various, different conditions, right? For repeatable testing, for both routine and unlikely scenarios, a fine-grained introduction of errors to determine system impacts, and community benchmarking, we need to have something different. We need to have a digital twin platform. So that's one of the things that we are developing. And again, thanks to Dinesh, Shinu, Trong, we have been doing this excellent work coming together. So just giving an example. So this Carla, many of you know, is for autonomous driving simulation. So in Carla, we can develop these use cases, these road scenarios. And we can have the various radars and cameras injected in Carla. And then we can move to Wireless Insight, where we can replicate that same scenario that we have created in Carla, and then essentially simulate the radio conditions, the wireless links. In this case, I'm showing the millimeter wave link. So this is very exciting because then we'll have the actual test bed, but we'll also have this digital twin that we are developing. And much work still needs to be done, but we are already being able to simulate some of the conditions, which is great. With that, I'll be ending. And any questions?